Hello everyone. So in this video we'll be learning how to solve Nash equilibrium in a game theory setup. We'll be doing this with the help of two examples in this video. The first example, let's just assume we have two players A and B. A has possible strategies of 1 and 2. B has a possible strategy of first and second. So their payoffs with this strategies are 40, 40. If both of them follow first and first strategy, we have 16 and 45. That is, if A follows first strategy and B follows second strategy, then they will be getting a payoff of 16 and 45 respectively. Then we have a payoff of 45 comma 16. That means if A follows second strategy and B follows first strategy, they will be getting a payoff of 45 and 16 respectively. Whereas if both of them follow the second strategy, they will be getting a payoff of 27 and 27. Now to calculate the Nash equilibrium, that is the best possible strategy followed by both the players. So let's take into consideration A first. So assuming that B follows first strategy, A will now see which strategy will give him the maximum payoff. So in this case, we have the second strategy, which gives him more payoff as compared to the first strategy if we assume that B follows the first strategy. Moving on to the second strategy. So if B follows the second strategy, then A will follow again the second strategy because second strategy is giving him more payoff as compared to the first strategy, right? So 45 is greater than 40 as well as 27 is greater than 60. So this is with respect to A, right? Now we'll test according to B. So if B assumes that A follows first strategy, then which is the higher strategy payoff? That is your second. So a second strategy will pay him off more than the first strategy. Similarly, if we assume that A follows the second strategy, then B will follow again the second strategy because second strategy is giving him more payoff as compared to the first strategy. Now we have to see that in which column or in which area both the circles are circled, right? We have both the circles, both the values marked. So that is possible in this case when both A and B are following second strategy. So this will be your Nash equilibrium, saying that this is the best possible strategy followed by both players A and B, right? So here we have identified Nash equilibrium. Let's take another example, a second example in this case, right? So we have two players, that is A and B. We have two strategies, 1 and 2, 1 and 2. The payoffs respectively are 50 comma 25. That is, if A follows first and B also follows first, they will get a payoff of 50 and 25 respectively. Then we have 10 comma 70. That is, if A follows first and B follows second, they will get a payoff of 10 and 70 respectively. Similarly, we have 20 comma 40 and we have 60 comma 35. So this is our payoff matrix. Now we have to identify the Nash equilibrium. Let's again follow the same procedure, saying that B, let's just assume that B follows first strategy. So for A, the best possible move out of the two will be, yes, you guessed it right, it is 50, right? And if we assume that B follows a second strategy, then again, which is paying A more, your second strategy, right? 60 is more than 10 and 50 is more than 20. Now we have to understand with respect to B, which is the best possible move for B. So if we assume that A follows first strategy, B will follow second strategy, because second strategy is paying him off more than first strategy. And then if A follows second strategy, then B will follow first strategy, because first strategy is paying him off more. 40 is greater than 35 and 70 is greater than 20. Now if you notice that there is no column where both the values are marked, right? This means that in this kind of a matrix there will be no Nash equilibrium, right? And that is why we can assume that in this case, A and B will be alternating their strategies according to other person's move, right? So this is how you solve Nash equilibrium. I hope this concept was clear to you and we made it easy. For more such training related to economics, do contact Economics Harbor. Okay, take care everyone. Bye bye.